neutralization class. We will be talking about neutralization reactions, which are when we combine a strong base with a strong acid to make them non-harmful. Okay? The first example that most of us already know of is heartburn. Have you ever felt that burning feeling in your esophagus after you eat some really spicy food? Well, that heartburn is because our stomach, in order to process food, has hydrochloric acid. That hydrochloric acid is very strong, but since our stomach is built for that, it is protected, okay? But our esophagus is not made to be holding that acid inside of us, so it doesn't have the same protection that our stomach has. That is why when we eat some very spicy food, our hydrochloric acid goes up in our esophagus and it starts to actually burn inside of us. That is why we get that feeling. Okay? What do we do when that happens? We take an antacid. What is an antacid? It's a base. It's a base that will neutralize that acid and make it water and a salt. Water and salt will not burn us inside. It will not damage us, and it will stop that feeling from happening. Okay? Now we have an example of neutralization reaction in our presentation. It is actually the neutralization that happens inside of us because most of the antacids contain magnesium hydroxide, which is a base that would neutralize the hydrochloric acid that we have in our stomach. Okay? This would form a salt named magnesium chloride and water, just hydrogen and oxygen. Salts, the table salt that we know of, is not the only salt that exists. Salts are formed when the anion of the acid and the cation of the base join together. Okay? Usually salts are made of one metal and one nonmetal, and that's because they are ionic compounds. Okay? But sometimes they are made from polyatomic ions. Okay, remember that topic? But the most common salts are made from one metal and one non-metal. Okay? The metal usually comes from the base. That is the cation, and it is negative. Okay? Cations, negative ions, are from the base. And the anion, the non-metal, comes from the acid, and it is positive. Anion is positive ion. Okay? According to the Arrhenius definition that we saw of acids and bases, the core of every neutralization reaction is that the hydroxide from the base and the hydronium ion from the acid, they combine to form water, and what is left outside are the cation and the anion, and they join together to form a salt. But what makes the reaction happen is the ion's tendency to form water. Okay? Now let's write a neutralization reaction from the exercise in your presentation to make zinc chloride. Zinc chloride is written CnCl2. Okay, this is a salt, and what do we need in order to form a salt? Remember that the anion comes from the acid and the cation comes from the base. Which of these is a metal? Zinc is the metal and chlorine is the non-metal. So what reaction could we write in order to obtain this salt as a result? As we saw in the neutralization reaction for heartburn and an antacid, we know that chlorine is an anion and it goes on the acid. So we would have the same acid, which would be hydrochloric acid. Okay? And our base would be zinc hydroxide. And as a result, it would give us the salt and water. Okay, so if you want to make a neutralization reaction, you just need to identify the metal and the non-metal. The metal would be the cation and the non-metal would be the anion, and combine them with either the hydroxide or the hydrogen to form an acid and a base. And the result would be the salt that you are looking for plus water. Remember, neutralization reaction is acid plus base equals salt plus water. Our second example is asking us what salt would be produced if we have a neutralization reaction of barium hydroxide and acetic acid. Acetic acid has a formula of HC2H3O2. And barium hydroxide is barium plus the hydroxide ion, which is OH. Okay, now what salt would we have if we were to make this reaction? First, we know that we would have water, okay? And for water, we're going to use the hydroxide Now, what do we have left? We have left the barium and the carbon, hydrogen, and oxygen. Okay, so we would combine them in the same way as it is in here. C2H3O2 plus water. Okay, now remember that we cannot have an unbalanced equation because of the law of conservation of mass. So in order for these to be balanced, we need to have 2 water molecules and 2 acetic acid molecules. And that's it. Remember, for water, we are always going to use the hydroxide ion and the hydrogen from the acid, hydroxide from the base, and hydrogen from the acid. And everything that we have left, we are going to combine it to make the salt. As we were saying earlier, salts can be made from polyatomic ions. This is an example of a polyatomic ions. Okay? So we have the barium, which is the metal from the base, and the non-metal ion from the acid, and we combine them to form the salt. Okay? Now, the next part of our presentation is the acid-base titrions. Okay? The titrions are neutralization reactions that are specifically made in order to know what the concentration of a solution is. And for that, we have a description of an example. Okay? The example that we have in the book and in the presentation is of a scientist that wants to know the concentration of a hydrochloric acid solution. He has 100 milliliters of this solution, but he doesn't know what the concentration of the acid is in that solution. So what is he going to do? He's going to make another solution, but with a base. Okay? Since he is a chemist, he is a scientist, he knows that sodium hydroxide neutralizes hydrochloric acid. Okay? So, to find the concentration, he's going to make a 1 molarity solution of the sodium hydroxide, and he's going to be adding little by little of the solution until the pH is exactly 7. When the pH is exactly 7, he will know that there are the same quantity of hydroxide ions as there are of the hydrochloric acid ions. Okay? So now that the pH is 7, it means that the neutralization reaction is complete and there is only left the salt and the water, and that means that the original amount on the solution can be found. Okay? So that is the purpose of the titrions, and it is used when you don't have the molality and you don't know the quantities that were added to the solution. You can use neutralization reactions to find them, as long as you're working with an acid or a base. That's it for this class. I hope it was all clear enough, and if you have any questions, please log in to the Facebook Live Q&A. Have a nice day. Bye bye.